Okay, so now for another challenge, we're going to look at what happens when you multiply a binomial by a trinomial, or a trinomial times a trinomial. Again, let's go back to the distributive property, and there we learned that you take what's outside the brackets and you multiply it by everything that's inside the brackets. So again, looking at this problem at the bottom, think about how you can extend the principles of distribution to solve this problem at the bottom. So again, maybe pause the video for a second. Think about how you might go ahead and solve that. Try it out, and then restart the video and see if you're right. So when we look at this particular problem, it's very similar to what we were doing with the FOIL idea, with the binomial times a binomial. It's easiest if you follow a process. And so what I usually do is I take the first term of the first brackets, in this case the x, and I multiply it by everything in the second bracket. So I'll do x times 2x, x times negative 4y, and x times 5. Then what I do is I take the second term in the first bracket, and again I multiply it by everything in the second bracket. So 3 times 2x, 3 times negative 4y, 3 times 5. Once I do all that, then I collect like terms. So let's go through that process. So I'm going to take x, times it by 2x, and get 2x squared. X times negative 4y, I get negative 4xy. And x times 5, I get positive 5x. Now I'm going to repeat that for the second term. So 3 times 2x, I get 6x. 3 times negative 4y, I get negative 12y. And 3 times 5, I get positive 15. So now what I'm doing is I'm going to look for anything that is a like term. So there is nothing alike 2x squared, there's nothing like xy, but there are two terms with an x. And so I'm going to collect my like terms and then write down what's left. So everything that wasn't a like term, I'm just going to write it. Now 5x plus 6x is 11x. And in the end, I will get an answer that has no like terms remaining. So let's look at one that's slightly harder. So this particular example is a trinomial times a trinomial. We're going to do that exact same process. The first times everything, the second times everything, and then the third times everything. In this case, we're going to end up with 9 things that we multiply, and then we'll end up collecting like terms. So let's start with 2x times 3x. 2x times 4y. 2x times negative 2. And then we'll do the second. 3y times 3x. Sorry, negative 3y times 3x. Negative 3y times positive 12y. Negative 3y times negative 2. And finally, 6 times 3x. 6 times 4y. And 6 times negative 2. So at this point, I'm going to collect my like terms if there are any. So I have 6x squared. There aren't any other terms like that. But 8xy and negative 9xy, those go together. One thing that you might want to try as you're collecting like terms is cross them out after you've written them. That way you're less likely to miss one. So we have negative 4x and positive 18x. We have positive 6y and positive 24y. And we have negative 12y squared and negative 12. And now let's collect everything together that's like and simplify. Remember, when it's 1, we can just write negative xy. So this one is quite complicated because there's a lot of things to keep track of and a lot of things to write, but it still uses that basic principle of binomial distribution, or In this case, really just the distributive property. And so that is your final answer.